What if I told you that the fastest thing in the universe never actually moves? We've been taught since childhood that light races across space at 299,792 kilometers per second. We imagine beams shooting from stars, photons traveling billions of light years, signals flashing through the vacuum. Movement, speed, motion. But what if that picture is wrong? Not experimentally wrong, not mathematically wrong, conceptually wrong, because when you look closely at the structure of spacetime, not poetically, but geometrically, something unsettling emerges. The equations don't simply describe light as moving fast. They describe light as tracing the boundary of reality itself. And along that boundary, something extraordinary happens. Time doesn't pass. For a particle with mass, you can talk about a journey. You leave here, you arrive there, and between those events your clock ticks, you age, you accumulate duration. But at the speed of light, the internal measure of time, what physicists call proper time, collapses to zero. Zero, from emission to absorption, no time elapses along light's path. So what does it even mean to say it traveled? Imagine a photon born in the core of a distant star, scattered for thousands of years inside stellar plasma, finally escaping into open space. From our perspective, it may wander across the expanding universe for billions of years before striking your eye tonight. Billions of years, but along its own path, there is no ticking clock narrating the voyage. The departure and arrival are connected by a light-like interval, a line in space-time with no duration. To say it moved, the way you move is to project your slow, mass-bound intuition onto something that lives at the edge of causality. Light doesn't experience time, it defines it, and here is where things become profound. Space-time isn't a passive stage where events unfold. It has structure. At every event in the universe there's a light cone, a geometric object that divides what can influence the future from what cannot. The surface of that cone is traced precisely by light, not inside it, not outside it, exactly on the boundary. Light does not wander freely through time the way massive objects do. It moves along the razor's edge, separating possible from impossible. In a very real sense, light doesn't move through spacetime, it defines spacetime. When you move faster and faster, your clock slows relative to someone at rest. At 90% of light speed, time is distorted. At 99%, dramatically so. Push the mathematics to the limit, exactly light speed, and proper time vanishes entirely. For a massive object, reaching that speed would require infinite energy. Nature forbids it, but light doesn't need acceleration. It simply exists at that boundary, and at that boundary, motion loses the meaning you've assigned to it. Because motion is usually measured as change over time, distance divided by duration, but if duration disappears, what remains of motion? What remains of moving? The photon does not sit still in space. From your frame, it crosses galaxies. But the deeper description, the invariant description, tells you that along its world line there is no unfolding sequence of moments. No before, no after, just a connection. We instinctively believe movement implies progress in time. Yet here is something that connects distant parts of the universe without accumulating time between them. That should disturb you, because if light doesn't move the way we think, then our ordinary idea of motion, of travel through time, is not fundamental. It is a special case, valid for slow, massive creatures like us. Light lives in a different regime of reality. It is not racing through time. It is the skeleton key of causality, the geometric constraint that shapes what before and after even mean. When a star explodes in a distant galaxy, its light reaches us after millions of years. We say we are looking into the past. But from the photon's perspective, if we can even use such language carefully, emission and detection form a single, timeless strand. The universe is stitched together by threads that do not age, so maybe the shocking statement isn't that light moves at a constant speed. Maybe the shocking statement is that light does not move in the way movement requires. It does not advance through moments. It does not experience duration. It exists on the boundary where time dissolves into geometry. And if the very thing that carries information, shapes causality, and defines the structure of spacetime does not experience time, then what exactly is time? And why are we so certain we're the ones who understand motion? Close your eyes for a moment and picture a beam of light leaving the sun. Instantly your mind animates it, a glowing streak shooting outward, racing across empty space, covering millions of kilometers in silence. We instinctively describe it the way we describe a car on a highway or a rocket crossing the sky. It moves. It travels. It goes from here to there. That picture feels obvious, but it hides a deep assumption that motion is something that happens inside time. When you say a car moves, you mean it changes position as seconds tick forward. You measure motion as distance divided by duration. Without time passing, motion makes no sense, no change, no speed, no story. Now here is the fracture in that intuition. Light travels at the maximum possible speed in the universe. And at that speed, the very thing that makes motion meaningful, time, behaves in a radically different way. In relativity, every object traces a path through spacetime called a world line. Along that path, there is a quantity known as proper time, the time measured by a clock traveling with the object. For you, sitting still, your clock ticks 1 second per second. For someone moving fast relative to you, their clock ticks more slowly compared to yours. Increase the speed, and the effect becomes stronger. At speeds approaching light, time dilation becomes extreme. Push the logic all the way to the boundary. At exactly the speed of light, the mathematics shows that proper time along that path is zero. Zero, not small, not slowed, vanished. For a photon emitted from a distant galaxy and absorbed by your eye, there is no accumulation of internal duration between those two events. From the structure of spacetime itself, emission and absorption are connected by a light-like interval, a path for which the temporal separation, measured along the path, disappears. We say light travels for billions of years. That statement is only true within our frame of reference, from the perspective of clocks, at rest relative to us. But along the path defined by light itself, there is no ticking clock narrating a journey. So what, exactly, is moving? The everyday word movement contains hidden baggage. It assumes there is a sequence of moments through which an object passes, a before and after, a continuous advance through time. That assumption holds for everything with mass, because such objects can never reach the cosmic speed limit. They always accumulate some proper time along their world lines. Light is different. Light does not rest. There is no frame in which a photon is stationary. The very idea of riding alongside a photon is physically meaningless because the structure of relativity prevents massive observers from matching its speed. That boundary is not technological, it is geometric. We imagine light as racing across the universe. But in a deeper sense, light is not racing in the way you race. It is existing on a boundary where our ordinary definitions of time and motion cease to apply. Consider how we construct spacetime diagrams. At every event, there is a light cone dividing possible directions into 3 categories: future, past, and elsewhere. The cone's surface is traced by light. Inside the cone lie paths slower than light, the kind you and I can take. Outside lie directions that cannot be reached without exceeding light speed. Light does not wander through the interior of spacetime the way we do. It lives exactly on the edge, on the razor, thin boundary separating causally connected events from those that can never influence each other. That boundary is not just about speed. It is about structure. When we say light moves, we are describing how its spatial position changes according to our clocks. But the invariant description, the geometric one, tells a subtler story. Along a light-like path, the spacetime interval is zero. The separation between events is neither purely spatial nor purely temporal. It is a special category, null. The null interval is the skeleton of causality. Every signal that carries information must respect it. Every cause must lie within another event's past light cone. In this way, light defines what can happen before what. It sets the architecture of influence, but something that defines the boundary of time cannot itself participate in time the way slower objects do. Imagine two distant mirrors facing each other across the cosmos. A photon leaves one and eventually strikes the other. To us, this process unfolds over vast duration, but in the invariant sense, those events are adjacent along the photon's world line. There is no experiential gap bridging them. This is not mystical. It is encoded in the metric of spacetime. The metric tells us how to calculate distance in this four-dimensional arena. For massive objects, the temporal part of that metric contributes positively to proper time. For light-like motion, the spatial and temporal contributions cancel exactly, producing zero. Motion without elapsed time is difficult to visualize because we are creatures embedded in slow processes. Every biological function you have requires duration. Your neurons fire over milliseconds. Your heart contracts in rhythms. Your aging is the accumulation of proper time. Light does none of this. It does not age. It does not experience sequence. If you insist on using everyday language, you can say it moves, but that word sneaks in human intuition that fails at the cosmic boundary. Perhaps a more accurate phrasing would be this: light connects events. It links cause and effect across spacetime without accumulating time along its link. What we interpret as a journey is, at a deeper level, a geometric connection drawn across the fabric of reality. When you see a distant star, the photon entering your eye has tied you to a past event through a thread that did not itself endure duration. The vast time between emission and detection exists for observers embedded in slower trajectories, not for the light-like path itself. So the illusion is subtle. We measure distance crossed over years and conclude that something has been moving for years. But the invariant structure whispers something more radical. Motion, as we define it, is not fundamental. Speed is the ratio of space to time, but if time collapses, that ratio loses ordinary meaning. At the cosmic speed limit, what remains is not motion through time, but alignment with the causal geometry of space-time. Light does not drift through moments the way plan, its orbit, or rocket's thrust. It inhabits the conversion boundary between space and time, the place where one can transform into the other under changes of reference frame. If movement requires duration, and duration vanishes at light speed, then calling light's propagation movement is more metaphor than mechanism. The beam you picture racing outward is, in deeper description, the universe stitching together events along its most fundamental boundary. When we speak about a journey, we imagine a sequence, a departure, a middle, an arrival. Between the starting point and the destination, something unfolds. Time accumulates, experience gathers, distance is crossed because moments pass. That is the grammar of motion we apply to everything in our everyday world. But this grammar quietly breaks at the most fundamental boundary of reality. In the geometry of spacetime, every object traces a path called a world line. Along that path, there is a measurable quantity known as proper time, the time registered by a clock traveling with the object itself. This is not an illusion or a coordinate trick. It is what your wristwatch measures as you move through life. It is what your cells count as they age. For massive objects, proper time is always positive. If you move slowly, you accumulate it at a steady rate. If you move very fast relative to someone else, you accumulate it more slowly compared to them. But no matter how you move, as long as you have mass and stay below the cosmic speed limit, your clock continues to tick. Now push toward the boundary. As velocity increases, time dilation grows. This is not merely a technical correction, it is an exponential restructuring of duration. Clocks in fast, moving spacecraft tick slower relative to those on Earth. High-energy particles in accelerators live longer because their internal processes unfold at reduced rates. All of it confirmed by experiment with astonishing precision. The closer an object's speed approaches that of light, the less proper time accumulates along its path between two given events. And at exactly light speed, that accumulated proper time becomes zero. Zero proper time means something deeply unsettling. Along that path, there is no internal duration separating the start and the finish. We often imagine a photon leaving a distant galaxy, traveling for billions of years before striking a detector. From our frame, billions of years have indeed elapsed. Civilizations have risen and fallen during its transit. The universe has expanded, structures have evolved, but along the photon's own world line, in the invariant spacetime description, there is no between. Emission and absorption lie adjacent in the sense that no proper time separates them. The journey collapses. Think about what this implies. Every narrative we construct about movement depends on duration unfolding. If no proper time passes along the path, then from that path's perspective, using language carefully, there is no story unfolding between the endpoints. You cannot speak of an experience of travel because experience requires internal change over time, and zero proper time forbids internal change. It is crucial to distinguish between coordinate time and proper time. Coordinate time is what a particular observer assigns to events using their chosen frame of reference. Proper time is what an object itself would measure along its trajectory. For light-like motion, the coordinate time measured by distant observers can be immense, but the proper time remains zero. So when we say the photon traveled, we are describing it relative to our coordinate system, not describing any accumulation of duration along its own path. This is not a philosophical flourish. It is encoded in the spacetime interval, the invariant distance between two events in relativity. For time-like paths, those of massive objects, this interval corresponds to proper time and is positive. For light-like paths, the interval is exactly zero. Zero interval, zero duration, no aging, no progression. The equations do not allow a rest frame for light. There is no meaningful transformation that puts you in a frame where light is stationary and time proceeds normally. Attempting that would require dividing by zero in the Lorentz transformation. The mathematics itself resists the idea. Light occupies a category distinct from anything with mass. Consider two events, a star emitting a photon and that photon being detected on Earth. In spacetime diagrams, these events are connected by a straight 45-degree line, the hallmark of light-like separation. Along that line, the metric ensures that spatial and temporal contributions cancel. It is as though the fabric of spacetime has a built-in slope for these paths. And along that slope, proper time does not accumulate. This forces us to confront a profound redefinition of what a journey means. For a spacecraft traveling at 999% of light speed, years may pass on Earth while only days pass aboard. Push the speed closer and closer to the limit, and the traveler experiences ever less internal duration between departure and arrival. In the limit, the traveler would experience no time at all between two events separated by vast cosmic distances, if such travel were physically possible. For light, this limit is not approached, it is actual. The endpoints are connected without internal lapse. What then does it mean to say light moves? Movement, as we understand it, is change with time, but for light there is no proper time along its path. Its existence between emission and detection is not spread across moments in the invariant sense. Instead, it is better described as a null connection, a bridge drawn across spacetime by the structure of causality itself. Light does not linger. It does not evolve along its path. There is no clock riding along that path, accumulating ticks. This is deeply counterintuitive because we are organisms bound to time-like world lines. Our reality is constructed from sequences. Memory depends on duration. Cause and effect unfold because internal clocks advance. Light challenges this model. It connects events without enduring them. When you observe a distant supernova, the photon that enters your telescope has not felt the billions of years we attribute to its travel. Those billions belong to observers situated differently in space-time, observers who are not traveling along that null path. The emission and detection are separated in our description because our clocks accumulate proper time in between. But along the photon's path, there is no such accumulation. This reframes the idea of causality. Light defines the fastest possible signal. It marks the boundary between events that can influence each other and those that cannot. In doing so, it establishes the structure of before and after. Yet along its own boundary path, before and after merge in the invariant description. A journey without duration is not a journey in the narrative sense. It is a geometric fact. The collapse of the journey at light speed reveals that time is not a universal container through which everything passes identically. It is a dimension whose role depends on the nature of the trajectory. For massive paths, time accumulates. For light-like paths, it does not. And in that razor-thin distinction lies one of the most profound revelations about reality. The fastest thing in the universe links distant corners of existence without living through the space between.